1. Okay, then we're taking your coefficients. Okay, so now, work on your domain. Your range is going to come at the end. Work your domain first. Move this down just a little bit.
Oh, no.
I'm going back, sorry. I just wanted to fit the whole thing in the screen. Okay. Again, work your domain first. Your range you're going to have to come back to. You don't know where your mins and maxes are right now. You don't know where your asymptotes are right now. Find your asymptotes. Follow your roots for your verticals. Your verticals, take your zeros of your denominator. We don't have anything to factor out right now. Today we will. Your horizontal gives you 3 rules. Your highest exponent. So they're both the 1. Take the coefficients of their coefficients of those variables and make a ratio, y equals. Once you get these 2, then you can sketch. Do your x equals 0, that's your y-axis, your y equals -1, and then you can sketch in between. It makes life a little bit easier, and it makes it make more sense that way, because you can see the parts you can't go to. You can also look in your table, and you can see when x is 0, when x is 0, it says error. It'll say error. So you know you can't use that one. Now, after you do this, if you don't have a max and a min, go for your range. Your range comes from -infinity, stops at the -1, jumps over it, and goes on again. You had no max and mins. We have a concave up. We consider this guy a concave up. We consider him a concave down. And it's a decreasing function. As you read x from left to right, your y is constantly decreasing. It takes a jump over your asymptote. It's your asymptote that finds your end behaviors. This is what deals with your end behavior. This tells where your ends are going to have to go. Before we said if your exponent was even, they would go up or they would go down. If it was odd, they'd be going in opposite directions. Now, because this is rational and you have a denominator in here, what guides your end behaviors are your asymptotes. They'll get closer and closer and closer and closer and closer to this line, but never touch it. You can even look in your calculator, look at your table, and see it. It'll never hit -1. It kind of guides the way for this. Good? Stop me if you have any questions.
Oh.
Otherwise, I'm going to kind of just go through them. Okay, let's stop while we actually get some new pencils.
You're okay, I'm sorry.
Oh, that's okay. We'll stop.
No, you can go, right?
Good.
Pretty fun.
All right. This one, remember, this one has a little issue with the negative sign. When you put it in your calculator, that negative sign can go out front. But here's your problem. When you resolve these pieces, that negative sign has to belong to somebody. So since you already deal with your denominator, and it would work out the same for your horizontal one anyway, make it go in the numerator. Just distribute it across the numerator. In your calculator, you can put it out front. That's fine. But if you dealt with your zeros of your numerator, your zeros of your denominator, and that negative wasn't someplace, then you used a different equation. So find your domain restriction like we always do. Your domain restriction leads you right into your vertical asymptotes, which is kind of nice. Once you distribute this, notice your horizontal, your highest exponent on your variable is a 1. Take your coefficients, make a ratio. Once you get your asymptotes, then you can sketch. I'm just going to move this down. Then you can sketch, and then work your intercepts. Go right back to your original equation. Those are your y's are the easiest. Your x-intercept, you still have to do your x-intercept, set y equal to 0, and solve for x of your numerator. Just do your numerator. Your zeros of your numerator. Again, no max and mins. You're concaving down, you're concaving up, and again, almost like the other one, you have a decreasing function. We see all different things with these because your denominator is kind of what runs these. Okay. Go back?
Yeah, I was finished.
Okay.
The domain and range.
up, I think it's up here. I just had to move it down.
Oh, okay. Thank you.
Yeah,
Sure.
sorry. I had to move it down to get the rest in.
No, I just wanted to check. I didn't see it.
Yeah, once you do your asymptotes and you determine that there's no max and mins, then go for your range. Usually we don't do the range to the end. And today you're going to see why. We have a few other little things going on. So, put these in. This probably is the one that threw everybody off a little bit because of that negative sign. And if you didn't use your negative sign, are you done?
No.
Okay. Then you would kind of see that your graph didn't match the graph that you put in your calculator. Okay, again, domain restriction says can't use a zero in your denominator. You have your exponent in the top has a zero. Your variable in the top has a zero exponent. So when the numerator is less than the denominator, you have one line, y equals 0. That's your x-axis all the time. So we have a y-axis and we have an x-axis here. We have, this is your increasing part, and this is also a concave up. This is your decreasing part, and this is also a concave up. Again, you have no max or no min. You had no zeros in your numerator, so you have no x-intercept. And you had no y-intercept. Good? Okay. Do your domain restriction. Find your asymptotes. Do you guys have the color calculators? Does it give you an asymptote line? Anybody that has the color? Does it give you a line, John, on your asymptote?
No.
I think there's a way to set something in your catalog or something to give you a line. I have to figure it out. Yeah, sometimes you'll get your vertical line. It'll give you a vertical line. Questions on these guys at all? They're kind of like almost the same. Do you kind of see a pattern here? Little pattern. We're doing domain restrictions. We're going right to asymptote. You already got your vertical so far. You got your vertical because we did your domain restriction. Use your horizontal rule. You had no variable in the numerator, so that's x to the 0. So your line is y equals 0. Your zeros of your numerator, none. Your y-intercept, you can get your y-intercept by just plugging your x as 0. And check these on your calculator as well. They're good to check. This is a little bit of a longer one. Your domain restriction jumped over the 2 and the negative 2. Almost like the one we did in class yesterday, right? But a little bit backwards. A little on the opposite way. Factor, there's nothing to reduce, and you would have nothing last night. But still get your factors, because that's going to help you later. These are your zeros of your numerator. Okay, that'll help you there. Your denominator, there's your verticals. You had to factor it anyway. You had to do that for your domain. Did I put a range up here? Yeah. A range was all real numbers. Even though y equals 1 is an asymptote, your function can cross through a horizontal asymptote. So then you're going to have to count that in your range. It can never cross a vertical because that's part of your denominator restriction. So you'll never see it cross a denominator one, but you'll see it cross a horizontal one. And today we're going to see another unique case. It crosses. This one you don't notice the end behavior in here because it comes completely down. But you're going to notice today we're going to cross over and then ride alongside of that asymptote. And that really kind of shows you your end behavior. This one I threw your inflection point in. I didn't want to hit everything, but Jordan caught it yesterday. So your inflection again, let me just move this down. Your concave up is the left-hand side one, and then you've got a slight concave up from 0 to 2. It changed its mind right through the middle, right through the 0, 0, and then concave down.
The whole thing's increasing.
Did I do an increasing? No, I didn't.
I don't know why.
The whole thing is increased. So let's, it might be, maybe it's up there. No, so let's do the increasing. So the increasing goes where? From negative infinity to where? That X, good. Then it jumps. And where does it go? Negative 2 to 2. 2 to infinity. It follows your domain. Same as your domain. At the end, your increasing, decreasing has to cover all your domain. And we didn't have any decreasing. Good? Yes?
Concave up and down, why is it 0 to 2?
Because concave, this is considered a concave up. So we're going from negative infinity to negative 2, right? This part here is considered a concave up. What it did was, it kind of changed its mind. You can't really see the parabola, but it should have been looking like this, right? So this is really a concave up in here. And then it changed its mind and concave down. So we consider this side a concave up, and this side a concave down. And this one is a complete concave down. That's where your inflection point comes in. Good? Get in here. And we're going to look at a point of discontinuity.
Oh, jeez.
Okay, we'll walk it step by step.
Words that I don't know.
It's okay. You're gonna learn those 2 new things today. I don't like to throw everything at the same time at you, so we'll do one at a time. So let's factor this guy. Is the top factorable?
Yes.
What does it factor into?
What?
No, right?
No, it's not.
No. So
I
is
thought you were
the
asking
bottom
me to be
is?
serious.
I always do that. And the bottom, not factorable, we have that. Always try to factor and look at it. You're going to have to factor your denominator to get your domain. So we're going to throw in our domain here. We're going to say that we can't use 2. So let's just get our domain. Let's jump over the 2. All right? From there, let's go to your asymptotes. Your vertical asymptote. Your vertical asymptote, because we couldn't factor anything, is what's left in your denominator. So nothing was factorable, so we set this equal to 0. And in your calculator where it says 2 in your table, doesn't it say error? So it says error. Now, here's your horizontal asymptote. Your horizontal asymptote has 3 sets of rules. It looks at the variable at the highest exponent. The highest exponent in the numerator is a 2. The highest exponent in the denominator is a 1. The third rule, when the numerator is exactly 1 more than the denominator, 2 is exactly 1 more than 1. Everybody got that part?
It just says if it's greater.
No, no.
If it's greater than you have no asymptote. If it's greater than you have no. Does it have another little thing in there?
No.
Oh, is it under the word slant asymptote?
Oh, yeah.
Okay, sorry. The third rule then, I don't have your sheet in front of me. Your third rule says you have no horizontal asymptote. But look down to the word slant. Your slant asymptote says when your exponent is 1 more than the denominator, 2 to 1, 1 more, we have a slant asymptote. Now, we find our slant asymptote by synthetic division. But it's quick because we don't care about the remainder. So we take out, we make sure the leading coefficient is 1. We set this equal to 0. There's a 0 here. We take out the 2, and we just synthetically divide this. Because an asymptote is a line, right? It's a line. What's the equation of a line? X, y equals mx plus b, right? It's only x to the 1, right? So, and we could have a quadratic be a slant, depending on how these work, but this is gonna give us an x1. So we're gonna pull these out, and we're gonna divide these.
Oh, you're doing the numerator?
No, we're just synthetically dividing this out. We take this, just like we did before.
Sorry,
We- Nope, you're good, you're
I
absolutely
don't
good.
even know what I just put.
We're just synthetically dividing this. Then this is a 0, this is a 4. Isn't this your remainder?
Yeah.
Just cross it out. Now, because we were x2 over x1, you got an equation of a line, because you're x1, that your result. I don't care about the remainder. All I care about is this part. I plot the x here. Here's my line. Y equals x plus 0. And I don't need the 0 in this case. So I have a line, y equals x.
What's this one, asymptote?
That's your slant, isn't that a slanted line, right? Okay, so now, let's build your asymptote. If you want in your calculator, you can go to y2 and put in your slant asymptote, y equals x. And you'll see your end behaviors go right along your slant asymptote.
Yeah.
Go to y2 and put in y equals x. Y equals x line is a line that cuts right through
It's
here.
right to the
This is your line of reflection as well. And your x equals 2 is over here. So now you get a better feel to graph. Oh, my graph went like this. Can you see it a little bit better now? Once we do our own asymptotes. And my graph somehow, somewhere, is going like this. Now here's a little hint. Sometimes with a slant asymptote in your calculator, and it might be happening, nope, your min is okay. Sometimes what happens is you don't see one of these sections because they're too high up. They turn too high up. This one has a smaller min, so you can see it on your 10 by 10 on your normal screen. But sometimes you're only going to see one section. If you have a slant asymptote and you see only one part down here, you know there's got to be another part.
Yeah.
So change your screen and find it. Even look in your table, you're going to see values in there for something. Okay, so now we know our asymptotes. All right, whenever you have a slant asymptote, you have no horizontal asymptote. Okay, so these guys also have max and mins because they turn. This is a relative, well actually this is a relative min, and this is a relative max. See if you can find them in your calculator.
So there's only max and min when there's one asymptote?
General. And a function can also cross a slant asymptote. The only thing it cannot cross is a vertical. Sometimes you may see it cross a slant, but look what this is causing your ends to do. Look at your ends. You see how they're guided by this? This is guided by this. Sometimes your calculator doesn't do a great job because it only can go so far with these asymptotes. So they kind of look like they stop. But see how they keep on going? They follow your asymptotes. That's what guides your end behavior. So what was your relative min?
4, 6.
4, 6.
And what's your relative max?
What?
1.838.
Oh, never mind. I got 0 negative.
I got 0, negative 2, yeah.
0, negative 2. Can everybody locate that max? Okay. In your calculator, locate your max. Second calc max. Bring it to this side, Jordan. Bring it to this side. Then did you hit yes? Okay, let's find our y-intercept. Let's find your y-intercept. Set x equal to 0. So 0, 0, I get a 4 over a negative 2. Did I cross at the negative 2? Yeah. That was right where my max was. My x-intercept, after we factored, is my zeros of my numerator. So I got to set y equal to 0 and solve this. But we can't factor it, right? Quadratic or complete the square. And what kind of roots should these be? Imaginary. Why are they imaginary?
Because it doesn't actually cross the x-intercept.
It doesn't cross the x-axis. Very good. So we're just going to say imaginary roots. That's all I want you to say. Imaginary roots, no real roots. No real zeros. All I want you to say is no real zeros.
You don't want us to like show any.
No, I just want you to say no real zeros.
Okay.
We can just say no x-intercept. When we do an intercept like that, yeah, we can easily say that. Like when you're doing synthetic division to find it, then you have to find it. But this one we can easily say this. Now, can we do a range? Can we find a range now? Is there anything else we need to find?
Or we don't have to do like.
We're going to do concavity and increase decrease. But we found everything we need to do those guys, right? Okay. What's our range? Negative infinity to where? What y do I stop at right here? Negative 2. Then I jump over it. What y do I resume at? 6. Okay, there's my range. Increasing, decreasing. The slant asymptote really, once you do it, it really is just helping you graph it. Everything else pretty much works the same. It just doesn't give it a horizontal asymptote when you have a slant. So everything else pretty much works the same. And I think you can get to see it a little bit better. You do have to do your synthetic division, but the rest should work. So now, increasings go off of your max and your min. So negative infinity to where? 0. And this is a decreasing part. Where am I decreasing? 0 to, what's this guy? 2. Right? This is our x equals 2 asymptote. Right? We can't get past that. So what's this guy doing? Coming down here. If we jump up here, decreasing. Decreasing from where? 2 to 4. Good. And then what am I doing? 4 to infinity. Good. Okay. Do I have a concave up and a concave down? These are a little easier to see, right? Here's your concave down. Concave down from where? Negative infinity to where? 2. To 2. Where's your concave up? 2 to infinity.